Here we're going to look at the three ways to solve quadratic equations. Sometimes we're able to isolate for x. At other times we can't do that, so we rely on either factoring or the quadratic formula. The second and the third method, both of these require that you rewrite an equation to equal 0 before you can solve. Let's now look at some examples on how we could actually isolate for x. To be able to isolate for x, we need to have a quadratic that's written in vertex form. So you can kind of look at both of these. They are in vertex form. The vertex form allows you to isolate for x. So let's see how we would solve the first one. This first equation, I can rearrange to isolate x. I'm going to first move the negative 12 over. It's going to become positive. So I have this term is equal to 12. Next, I'm going to divide both sides by 3, and that's going to make it x plus 1 squared is equal to 4. Now I want to undo the square. I want to get rid of the square by doing a square root. Anytime you go from a square to a square root, you get two possible answers. So I have to write plus or minus the square root of 4. Simplifying, we have x plus 1 is equal to plus or minus the square root of 4, which is a 2. Now I get to solve two separate equations. So x plus 1 is equal to 2, or it could be that x plus 1 is equal to negative 2. Rearranging, 2 minus 1 is 1. And then here I move the plus 1 over, it becomes negative 1. Negative 2 minus 1 is negative 3. So these are the two solutions to this quadratic equation. Let's look at the next one. It's not equal to 0, but that's not a problem for us. We can start the same way. Move the plus 1 over. It becomes a negative 1. 73 minus 1 is 72. Then we want to get rid of the 8. Divide both sides by 8. X minus 5 squared is equal to 72 divided by 8 is 9. And now we take the square root and we get two answers. X minus 5 is equal to the plus or minus square root of 9, which means x minus 5 is equal to plus or minus 3. And now we solve two equations. X minus 5 is equal to 3, or x minus 5 is equal to negative 3. Rearrange, and there we go. Both times you're able to isolate for x. 3, negative 5 becomes a plus 5. 3 plus 5 is 8. Here too, I move the 5 over, becomes a positive. Negative 3 plus 5 would be a 2. And these are the two solutions. So if you see your quadratic equation has the vertex form, this is the vertex form. If you see anything like that, you're going to be able to isolate for x, and you could do so and solve what x could be. Now let's look at the second way to solve quadratic equations. Factoring. If possible, we can factor. For the factoring technique to work, your equation needs to be rearranged to equal 0. So I'll start by doing that with example A. I have x squared plus 9x minus 3. I move the 2x over, becomes negative 2x. I move the plus 5 over, becomes negative 5, equals 0. I collect the like terms, x squared. I have then plus 7x, and then minus an 8, equal to 0. Now we start by factoring. I want to multiply the a and the c, so 1 times the negative 8. So I need two numbers that will multiply to negative 8 and add to the b value of 7. I want them to add to 7, and I want them to multiply to negative 8. Those two numbers are 8 and negative 1. So now I can factor into x plus 8 and x minus 1 equals 0. For those of you that are not familiar with factoring, please watch my factoring videos before you do these examples. So we have a product that's equal to 0. That means x plus 8 equals 0, or x minus 1 equals 0. Rearranging, x will be negative 8, or here x is going to be equal to 1. Those are the two solutions. Next example, it's going to be a bit more complicated because it's a complex trinomial. My a is 6, my b is 13, and my c is the negative 5. Let's multiply the a and the c. 6 times negative 5 is negative 30, and the b value is the 13. So you want two numbers that will multiply to negative 30 and add to a 13. Let's make a list of ways to get to a product of 30. 1 times 30, 2 times 15, 3 times 10, and there's 5 times 6. You gotta pick from this list two numbers that will satisfy both of these properties. You can pause the video and think about what those numbers are, and then play it. Okay, so assuming you've thought about it, those two numbers turn out to be 15 and negative 2. Negative 2 times 15 is negative 30, and negative 2 plus 15 is 13. So now we do it with my favorite way of factoring complex trinomials. It's not going to be as easy as this one, where you can just put your numbers in the brackets next to the x. I'm going to show you the ratios. If you're not familiar with this, please watch my video on factoring complex trinomials. But I start two ratios with a 6x, and in my ratios, I use the numbers I've written down. So my first ratio is 6x to negative 2. My second ratio is 6x to 15. And I try to reduce these ratios without creating fractions. The first ratio I could reduce without creating fractions by dividing both sides by a 2. That gives me 3x to negative 1. The second ratio, I can divide both of these by 3 without creating fractions. That leaves me with 2x to 5. And these ratios are going to help me with my brackets. So my factoring is 3x minus 1 and 2x plus 5. And now we can solve. Either 3x minus 1 is equal to 0, or the 2x plus 5 is equal to 0. We rearrange. 3x is equal to 1. Divide both sides by 3, and you get one solution as 1/3. And the second solution is going to be negative 5/2. So these are two good examples on how to solve quadratic equations with factoring. But you can imagine that it's not always possible to factor, and that's why the quadratic formula was invented. So let's do some of that. Now let's look at some examples with the quadratic formula. If you have a quadratic equation in standard form, ax squared plus bx plus c is equal to 0, then the quadratic formula says that your solutions are going to be found with this calculation. This is an easy way out if you forget how to factor, or if you're just not in the mood to find out what the factored form might be. And it's even better applied to situations where factoring is impossible. Let's look at this example here. It's not telling me how to solve it, it's just asking me for a solution. So I'm going to try and show you how factoring wouldn't work, but then the quadratic formula will help me out. So I write my ABCs. My A is the 2, my B is the negative 8, and my C is the 5. If I was trying to factor this, I would be looking for two numbers that will multiply to a 10 and add to a negative 8. Two numbers that multiply to 10 and add to a negative 8. The way to get a 10 is with a 1 and a 10 or a 2 and a 5. And you can see that neither of these pairs of numbers will give you what you're looking for. There is no way to create a negative 8 out of any of these two pairs. But that's okay. That's why we have the quadratic formula. So after you write your ABCs, you can directly plug them into the equation. X equals negative of the b. Well, my b already has a negative, So if I put another negative on it, it becomes positive 8 plus or minus the square root. Negative 8 all squared minus 4 times a times the c all over 2 times the a. And now we're going to simplify this. 8 plus or minus the square root. 64 minus 40. Okay, you got to multiply these three numbers. 4 times 2 times 5, that's 40, and you have a minus 40 all over 4. 8 plus or minus the square root of 24 all over 4. It's not over though. Let's simplify it more. You gotta find a perfect square, the largest perfect square that goes into 24. If you don't know what I'm talking about, please see my video on radicals. 24 can be broken up into the square root of 4 times the square root of 6. Square root of 4 is 2. And now I suspect that maybe I'm going to be able to do some cancellation, something I can reduce this with. And it's possible to do that, but if you want to do a cancellation, let's say you're tempted to cancel the 4 with the 8. Don't do it like that. Try to find a common factor up here and then reduce the common factor with the 4. So you can look at the 8 and the 2. They're both divisible by 2. Take a 2 out. If I take a 2 out, it's 2 times 4, and then it's plus or minus the square root of 6 all over 4. And then reduce it from there. Look at the 2 and try to reduce it with the 4. 2 divided by 4 is 1/2. So I cross that out to a 1, cross that out to a 2, and then I no longer need the 1. When I have a 1 times a bracket, I can just leave it out, and I have 4 plus or minus the square root of 6 all over 2. And now I have my two solutions in the most simplified possible form. I have 4 plus root 6 over 2 or 4 minus root 6 over 2. This is the simplest form of these two solutions. Let's do another one. But if you follow this video, you can pause it, try the next example on your own before you play it. Here's the second example. A, coefficient of x squared is 3. Coefficient on x, it says plus x, so I'm thinking there's a 1 there. If there is no number, it's a 1. C value is negative 7. And now I can solve. So negative on my b, plus or minus the square root of my b value squared minus 4 times a times c all over 2 times the a. Negative 1 plus or minus square root of 1 squared is 1. Then I have to sort this out. So I'll do it on the side. Negative 4 times 3 times negative 7. I can multiply these together to a negative 21. And now I have to deal with negative 4 times negative 21, which gives me positive 84. Simplifying, I have root of 85 all over 6. And this is as far as I can go with this question. You see, if I look at my perfect squares list, none of the numbers in the perfect squares list are divisors of 85. So if I look at all of these, I mean 1 is, but 1 times 85 doesn't do anything. 49, right? There is 64. None of these divide into 85. So we don't simplify this like we did with the 24. So here are my two exact solutions. There's this one, and there's the negative 1 minus root 85 all over 6. There we go. This is how we can use the quadratic formula. So I hope you learned how to use all of these three different methods. You should know all three because you never know in which situation which one will be better. You could also be instructed to follow a specific solution. So know all three so that when you're asked to do it one certain way, you know what to do. Thank you for watching.